Good evening, everyone. It gives me immense pleasure to welcome you all to day 4 of our faculty development program. Today, we are truly honored to have with us Dr. Y. Jahnavi ma'am. Is an accomplished academician and researcher with over 20 years of teaching and research experience in the field of computer science and engineering, specializing in data science and data analytics. She earned her PhD from Geetham University, Visakhapatnam, and is currently serving as an assistant professor at Government Degree College, Naidupet. She has qualified UGC NET, GATE, APSET, and APPSC examinations and is a recognized PhD supervisor at multiple universities, including Andhra University, VTU Bangalore, JNTU Anantapur, and Annamacharya University, Rajampet. In her administrative roles, she has served as the head of the Department of Computer Science and Engineering at Geetanjali Institute of Science and Technology. She has also acted as the remote center coordinator for MHRT, NMEICT, IITB faculty development programs, generated over 21.8 lakhs, 87 lakhs fund and organized national and international conferences consecutively for the 5 academic years. She has also served as SPOC for Swayam NPTEL and coordinated spoken tutorial training programs. She has authored several books and research publications in reputed ACM, IEEE, Springer venues, and also published patents in artificial intelligence and machine learning applications. Her academic contributions include organizing national and international conferences, FDPs, and delivering numerous keynotes and guest lectures across the country. We are indeed privileged to have her with us today to share her experience and insights on this significant domain. Now, I take great pleasure in handing over the session to Dr. Y. Jahnavi ma'am to lead us through this enlightening and informative session. Over to Jahnavi ma'am.
Thank you, Anisha. Thanks for your nice introduction. Now, I'll be discussing in today's lecture, I'll be discussing data science algorithms and applications, how various algorithms in Python are going to be implemented. Initially, let me discuss what's meant by data. You must have heard data everywhere. Now, from our BTech curriculum to BTech, MTech, wherever you go, we are listening the word called as data. This data is of different types. One is structured data and second one is unstructured data. And you must be hearing the word called as semi-structured data also. So when coming to the structured data, data is in the form of rows and columns. So for processing such structured data, we use structured query language SQL, which is in the form of just rows and columns. There is a particular structure for the data. By using structured query languages such as MySQL, we can easily extract data. It's very easier process to extract required data from structured data. But when coming to unstructured data, the data is in the form of text, audio, video. So these data, all these are in the form of unstructured data. Suppose, for example, if we consider any research articles, they have some structure, like they have title, abstract, keywords, then introduction, like literature survey, methodology. So there is some structure for that. That type of data is called a semi-structured data. So processing structured data is a bit easier than unstructured data. We can extract required patterns from structured data. For example, if we consider any student database, by using any structured query language, we can extract the students whose marks are greater than 90% or whose marks are in between 70 and 90%. It's easier to extract our required relevant data from structured database compared with unstructured data. From unstructured data, extracting patterns is a bit complex compared with structured data. So when you see unstructured versus structured data in mid-90s, not at present, in mid-90s, if you see, data volume of unstructured data is much more in mid-90s. Data is being generated in those days. But market cap is very less in mid-90s in the case of unstructured data. Whereas in case of structured data, data volume is less, but market cap is much more. So we are processing only structured data. by many users, end users need structured data. Processing of structured data is required there. But at present, today, if you see unstructured versus structured data, unstructured data volume is much more and market cap is also much more in case of unstructured data. Whereas in case of structured data, volume is very less. The data that's being generated is very less. Structured data is being generated is very less. Market cap is also okay. But comparatively, unstructured data is being generated much more at present. And market cap of unstructured data is much more compared with structured data. So at present, today if we see this, unstructured data is a concept. Then from where data is being generated? So till now, before going before going to the concept of data science or data analytics, we are discussing data and types of data, structured data, unstructured data, and semi-structured data. So at present, if we see in today's market, unstructured data, market cap and generation of unstructured data is much more compared with structured data. Then in that case, where the data is being generated, where this unstructured data is being generated and data is being generated. So Walmart is generating large data warehouse with 500 terabytes of storage. eBay storage amounted to 8 petabytes. The Yahoo warehouse totally 170 petabytes. This amount of data is being generated. Now, for every 60 seconds, 98,000 plus tweets are coming. 6,95,000 status updates, 11 million instant messages, more than 6 lakhs Google searches, 168 million emails are being sent daily. No, not daily, for every 60 seconds. 1,820 terabytes of data is created for every 60 seconds. Now, mobile web users. So this much amount being generating regularly. We are tweeting, we are sending messages, we are doing Google searches. Now we are generating the data and we are using the data. Petabytes of data. These much amount of data we are generating for every 60 seconds. So in the olden days, we were listening only KBs, kilobytes, megabytes, gigabytes. Now zettabytes, petabytes. So these are the units of data measurements: bit, byte, kilobyte, megabyte, gigabyte, terabyte, petabyte. But exabyte, zettabyte, yottabyte. So this is the yottabyte. This is the currently the largest defined standard unit. So KBs, MBs. So that is normal terminology. But now this much amount of data is being generated. We are generating. We are the generators. We are the consumers. We are doing everything daily. So when this much amount of data, whether this data is structured, no. This data is unstructured data. Mostly the data that we are generating, the mails that we are sending, WhatsApp messages that we are sending, tweets that we are doing, everything is unstructured data. This is not this have very little structure. If it has very little structure, we just call it as semi-structured data. Then who is generating big data? No, if the size of the data is even much more, we use the terminology as big data. Social media networks, scientific instruments, mobile devices, sensor technology networks, all these devices we are generating all this data. In the olden days, few companies are generating data, all others are consuming data. So generation is being done only by a few companies. People are consuming, but now at present in the new model, all of us are generating data and all of us are consuming data. We are the generator, we are the consumers for the data. So when you see this artificial intelligence, it's a broad area. At present, we are using the word called as artificial intelligence. It's a broad area which contains sub-areas like machine learning, data science, data analytics, big data analytics. All this comes under artificial intelligence. When you see data science and data analytics, for data science, we are using the programming languages like Python and R. So these are the languages that we are using. We are considering a structured, unstructured, and semi-structured data and applying machine learning algorithms In data science, we are applying machine learning algorithms for extracting our relevant patterns. That is called as data science. In data analytics, we are visualizing the things, representing in the form of graphical forms. For that, we use BI tools like Tableau and Power BI. For data analytics, we use mostly BI tools like Tableau and Power BI. For data science, we use the programming languages like R and Python. If the data that's being generated is even much more, we call it as big data. So data science is interdisciplinary. So it's not a single discipline. You cannot say that data science is a single discipline which cannot be interrelated with other disciplines. We cannot conclude in such a way. Data science is interdisciplinary, which is related to machine learning, which is related to statistics, pattern recognition, artificial intelligence, data mining, databases, data pre-processing, visualizations, business analytics. So all these fields are interrelated. You cannot segregate data science separately from machine learning or data science separately from statistics. Data science cannot be separated from data analytics. There is no crisp distinction. It's an interdisciplinary field which is related to various other disciplines. Then data science libraries in Python, data science packages or data science libraries in Python. So that's our main agenda in today's lecture. So there are various data science libraries in Python. We are going to discuss these data science libraries. So there are some machine learning libraries in Python and there are some deep learning libraries in Python. Let me discuss these libraries, machine learning libraries in Python. These are the Numpy, Scipy, Matplotlib, Seaborn, Pandas, and Scikit-learn. These are the very important machine learning libraries in Python. So Numpy, let me discuss these libraries. For these libraries, either we have to use Anaconda, Jupyter Notebook, or we have to use Google Colab. That's better. Rather than using PyCharm and all, it's better to use Anaconda Jupyter Notebook. I'll open the Jupyter Notebook. I'll see some of the simple programs that can be executed in Python. These libraries are very important. So for this data science, it's better to go with Python. R and Python, these are the most important programming languages used by data scientists. But academically, R is preferable. But whereas in industry purpose, Python is much better than R. So when you see this NumPy, numerical Python. NumPy stands for numerical Python. This NumPy it's a fundamental package for numerical computations in Python. Actually, there is an array package. Either you can import array package or you have to import NumPy package. When you import array package, array supports only one-dimensional array. But whereas to support more than one dimensions, that is 2, 3, and n dimensions, we have to go for NumPy. So we need to import NumPy package. So there are the different ways of creating NumPy. Let me open Anaconda Jupyter Notebook and show you a bit. So I've already opened. I'll open. You have to install Anaconda Jupyter Notebook. It's being opened. There you have to launch Jupyter. I've installed Python 3. So its extension is IPYNB, IPython notebook. So you can create new Python 3. We already installed Python 3. So to open a new notebook, you can go to new and Python 3. I've already created IPYNB file. If you're using PyCharm, the extension is going to be .py. So this is the first package, Numpy. Before moving to Numpy, let me discuss what's meant by an array. So from array, you have to import. From array import star, all the things I've imported and created an array method with these 5 elements 10, 15, 2, 10, 72 and 9, and I'll be printing this array. This is a simple one-dimensional array which I've created by importing array package. Then we can display those elements for I in array print of I. So we'll be displaying all the elements in the array. So by using the name of the array, otherwise range of 5, which contains 5 elements. So these are the, in Anaconda Jupyter notebook, I've opened Python 3. In this notebook, there are different cells. You can just open it and run this cell. Run cell. When you run this cell is being run print array. It prints this array. Then in the same way, you need to run each and every element. Will be running each and every element and displaying these elements. Then for I in range of 5, print array of 5. It will be displaying one by one rather than printing all the elements. It will be displaying one by one. For I in range of length of array, length method is used for finding the length of the array. Print array of 5. All the elements are being printed. This array method, array package supports only one-dimensional arrays. Same like C and Java, in the same way, indexing is there. So by using indexing, array of 0 displays first element, 1 displays second element, and so on. So this is how we've imported the array package and created a one-dimensional array. But the drawback of array package is that it supports only one-dimensional arrays. To support multi-dimensional arrays, we need to go for Numpy. These are the various operations on arrays. Now in the same way in Python also, you can do it. But Python, the advantage of Python is that it has rich set of packages. The first one is Numpy. So in Numpy, before going to Numpy, I've introduced array. So array supports only one-dimensional arrays. Then we need to import Numpy. To support more than one dimension, we need to go for Numpy. So import Numpy as NP. Then Numpy has different methods. As I've mentioned in PPT, these are the different ways of creating arrays in Numpy. First method is array. Second method is linspace. Third one is log space. Fourth one is arrange, then zeros, ones. These are the 6 important methods that are available in Numpy. Numpy stands for numerical methods, which contains these 6 important methods. By using array, we can create an array that will be either 1 dimension, 2 dimension, or n dimensions. I'll show linspace, log space, arrange, zeros, and ones. So this is the one-dimensional array that we have created. Then I'll be printing number of dimensions. So for every cell, we need to run each cell. I hope that you are familiar with Anaconda Jupyter Notebook and moving a bit faster. We have created an array and printing the array. When I run this cell, now print of A, prints the elements within the array. Number of dimensions. For finding the number of dimensions, endim is used. Endim displays the number of dimensions. It is a one-dimensional array. Shape gives shape. So when you see this output, number of dimensions of A is 1. Shape, the elements are 5, 5, comma. Size, how many elements are there? 5 elements are there. So it just displayed 5. Then I'll move to, so these are the 3 important methods, endim, shape, size. So this is the 2-dimensional array, 1, 2, 3, 4, 5, 6. This is 2 by 3 array. When you print B, it displays 1, 2, 3, 4, 5, 6. This is the output. Number of dimensions of B. The number of dimensions are 2. It is a 2-dimensional array. Then B dot shape and B dot size. Shape is 2 by 3 and size is how many elements are there that are going to be displayed. Shape is 2 by 3 and size 6 elements are there. In the same way, we can create 3-dimensional array. This is a 3-dimensional array. As you can see, 3 square brackets here. This is a 3-dimensional array. We'll be displaying that array. Then the number of dimensions, shape, and size. Then these are the various operations that can be performed on arrays. So for that, you can add, subtract, multiply, all can be done either on 2 dimensions or 3-dimensional arrays. All operations can be performed by importing Numpy package and then creating an array which contains shape, size, and endim methods. This is the first one, array. Then second one, linspace. I'll show you linspace. So if you come here, from Numpy import star, linspace method is there. So you'll see array, linspace, log space, arrange zeros and ones. From Numpy import star, A equal to linspace of 0, 15. 0 to 15, it considers 0 to 15. These elements are divided into 16 parts. These elements are divided into 16 parts and will be displayed. Print of A. Print displays all the elements 0 to 15 and the number of elements are and the number of parts are going to be 16. If I change this 16 to, for example, 5, 0 to 15 divided into 5 parts. Run this cell. 0 to 15, which are divided into 5 parts. So 0 to 3.75, 75, 75, 11.25 and 15. Rather than considering 0 to 15, let me consider 0 to 10. Divide it into 11 parts. 0 to 10. 0 to 10 contains 11 elements, including 0 as well as including 10. When I run this one, 0 to 10, 11 parts. If I divide it into 5 parts, 0 to 10, 5 parts, 0 to 10, 0, 2.5, 5, 7.5 and 10. This is how linspace method is going to work in Numpy. First, we need to import from Numpy import star, then linspace. Then next one is log space. Log space also do in the same way as how linspace performed. Linspace method have performed. But the difference is it calculates logarithmic values. It is 0 to 15 divided into 16 parts and it calculates logarithmic values. Logarithmic values of each one. If I divide it into 10, it displays and finds logarithmic values. That is linspace, log space. We've seen array in Numpy, linspace, log space. Then ones and zeros is very simple. Ones of 5, it just displays ones of 5 means it displays 5 ones. Zeros of 5 means it displays 5 zeros. You can create how many ones that you want and how many zeros that you want. Ones of 10 displays 10 ones. Zeros of 20. This is an array of size 20. After creating this one-dimensional array with 20 elements, you can reshape. You can do reshaping. You can convert 1D to two dimensions or three-dimensional arrays. You can perform reshaping also. These are the operations and arrays. So the important method here is matmul. Matmul. This matmul method is used for finding matrix multiplication. Where in C and Java, it's difficult to do matrix multiplication. There is a lot of code that has been embedded there. Whereas in Python, it's just import numpy and np.matmul. That's all. It will perform matrix multiplication. Say arrange. So we have seen array method, linspace, log space, zeros, ones. Then the next one is arrange, a range of 30. A range of 30. No, in linspace, 30 is also being included, whereas in our range, excluding 30, it displays 0 to 29. 0 to 29 by excluding 30, and will be displaying print of t. It displays 0 to 29 elements. Then d dot shape is 30, comma. Size, how many elements are there? 30. And n dimension, the number of dimensions are only 1. So if you see this, a range of 30 dot reshape of 5, comma 6. We can reshape to 5 rows and 6 columns. np dot a range of 30 dot reshape of 5, comma 6. Print e dot shape, e dot size. If you see this is reshaped to 5, comma 6. Its shape is 5, comma 6. Even you can print E and check it. You can print E. This 0 to 29 elements are reshaped to 5 rows and 6 columns. So shape is 5, comma 6 and its size is 30 elements and the number of dimensions are 2. It's converted to 2 dimensions. Here it was 1 dimension. In the previous case, it was 1 dimension. We've reshaped it to 2 dimensions of size 5 by 6. So if you see this arrange, it is not arrange, arrange, a range of 1 to 30, comma 5. So till now we have seen a range of 30, but now we have given starting index, ending value excluding 30. It will not include 30 and each value will be incremented by 5. Linspace divided into 5 parts, but this arrange, each value will be incremented by 5. Initially, it will consider 1. 1 plus 5 is 6. 6 plus 5 will be 11. 11 plus 5 is 16. 21, 26. Print E. These are the elements. E dot shape. Its shape is, this is 1 dimension with 6 elements and size is 6 and its dimensions are only 1. So this is arrange. So we have seen these are the ways of creating arrays in NumPy. First method is array. Second method is array just creates the array that will be either 1D, 2D or ND. Linspace, it considers the elements from starting, including the ending element, which is divided into the number of elements that we have given as a third element. If I have given 5, it will be divided into 5 parts. Log space, it is same as linspace with logarithmic values. Arrange, it considers starting index and without excluding the ending value to this previous element, each value will be incremented with the third element. Zeros, if I want to create an array with only zeros of size, some 5 zeros or 2 by 3, an array with zeros. So this zeros method is used for creating zeros. Ones method is used for creating ones. So this is Numpy is the first important machine learning library in Python. Numpy is very, very important one. Numpy stands for numerical Python. It's the most fundamental package which is used for numerical computations. This is the most fundamental package. It contains n-dimensional array object and it's an array processing package. For using NumPy, you have to import NumPy as anything. These are the ways of creating NumPy. Now, you can there are various methods that are there in NumPy. Can do addition of array, subtraction. Sub is used for multiplication, mul is used for divide, division is used. But mul performs element by element multiplication. But for mathematical multiplication, we have to use the method called as matmul. And the most important operations like indexing and slicing. Indexing, we know that we can extract the required element by using indexing, and slicing is also there. Slicing, from which element to which element that we want to extract. Even in indexing, if I've created an array A, E of 0 gives starting element, E of 1 gives next element, but E of -1 gives ending element, E of -2 gives last but one element. Reverse indexing is also possible here. Then slicing. Slicing is from which element to which element that we want. A range of elements. That is possible by using slicing. And mathematical and statistical methods like mean, variance, standard deviation, min, max, square root, exponential, all this also can be performed on NumPy. All these operations can be performed on NumPy. No, these operations even we can do with Scipy also. Actually, Scipy, the first one is NumPy. The second important package in data science is Scipy. Scipy is a scientific Python actually. So it's built on top of NumPy. It's used for scientific computations like for finding mean, median, mode, standard deviation, range, correlation coefficient. For all these things, Scipy is also used. Then the third important library in data science is Matplotlib. So first one is NumPy, second one is Scipy, third one is Matplotlib. This Matplotlib, generally we use Matplotlib for plotting, for visualization purpose, for plotting bar plots, any scatter plots. For plotting purpose, we use Matplotlib. So let me see this Scipy and Matplotlib in Anaconda Jupyter Notebook so that it will be clear for you. I hope that NumPy package is clear for you. These are the 6 different ways of creating arrays: array, linspace, log space, arrange zeros and ones. So these things just now I've discussed. So either we can create an array with the elements here itself or read the elements. No, by using the input method and converting the type of the value to typecasting to integer and append it. So this is how either we can read the array elements and perform all these operations: addition, subtract, matrix multiplication. For matrix multiplication, matmul is used. Now I'll move to plotting after completion of Scipy. Scipy is the important one, which is built on top of NumPy. This is Scipy. These are the 3 measures of central tendencies: mean, median, and mode. This is an organization A and the salaries of employees in this organization A. 35K, 40K, 60K, 50K, and so on. This is an organization B and the salaries of employees 55K, 55K, 61K, and so on. So these are the 2 organizations with some employees' salaries. So now I've asked you to find, no, for measuring central tendencies like mean salary of this organization, median salary, mode. So for this organization, we need to import Scipy as SP. Either we can perform this mean median either by using Numpy or Scipy. Scipy is also built on top of Numpy. So import Scipy as SP and then SP dot mean of organization A. This is first cell. We need to run this cell. Then import Scipy as SP. Run this cell. When you're running, the cell is the status of this cell is star means it's in the status of running. 1, 2, numbering is being done. Import Scipy as SP. Then third cell SP dot mean of organization A, SP dot mean of organization B. Run this one. Mean of organization A. This organization A mean salary is 47 point something. Mean of organization B is 53 something. So the same thing you can perform either by using NumPy also. NP dot mean of organization A, NP dot mean of organization B. You can just run this one. The same value you're going to get it. Then median. Actually, mean is not a recommended value if you have extreme values. So in one case, if you have extreme values, only if you have employees, 10 employees of those employees are having some salaries. But if you consider a manager may be drawing more salary than these employees. So in that case, mean is not a recommended measure. That case, we need to go with using median. Median of organization A. NP dot median of organization A. NP dot median of organization B. Either you can import Scipy and then write SP dot median or import Numpy and write NP dot median. This is the median salary, middle salary and median of organization. Then mode. This is the highest frequency data in the distribution. So how many times if a person is drawing, 45K 2 times and remaining all are drawing only once. So the same salary at maximum how many times it has been repeated. That is highest frequency data in the distribution. From Scipy, import stats. Stats dot mode of organization A, stats dot mode of organization B. So that we get this is the 45 with count of 2 and in the second organization B 34 with count of 4. So this is mean, median and mode by importing Scipy. This Scipy is used for exploratory data analysis. Then measures of data variability, range, maximum minus minimum. Max of trained A minus min of trained A. This is range. Then standard deviation. So again, for standard deviation, NumPy, this is the procedure for finding standard deviation. Rather than using the entire procedure, you can use a method called STD, which is in the NumPy. NP.std of train A. NP.std of train B. This is the standard deviation. So we have seen NumPy. First, important package, machine learning package, which is going to be used in data science. All are interdisciplinary actually. So first one is NumPy. NumPy stands for numerical Python and second one is Scipy. Scipy, it's used for exploratory data analysis. Then the third one is Matplotlib. Matplotlib is basically used for drawing purposes, for plotting libraries. So this is Matplotlib. For that, you have to import matplotlib.pyplot as PLT. Then this is the organization A with 10, 20, 30, 40, 50. We'll be drawing box plot of organization A. This is the box plot. First thing is you have to import matplotlib.pyplot as PLT. We are renaming as PLT and we'll be using PLT.boxplot of organization A. It displays this box plot. And then correlation coefficient, even by using Scipy, import Scipy as SP, you can find correlation coefficient also. SP dot correlation coefficient of sales and discount. For sales and discount, if we find the correlation coefficient of sales and sales, we'll be getting 1, 1, 1. But if we find the correlation coefficient of sales with the discounts, it's going to be sales 1 and then 0.82, 0.82 and 1. This is the, for sales and discounts, this is the correlation coefficient. You can just import SciPy and then find the correlation coefficient. So by using matplot, we have seen box plot. Now we'll be seeing scatter plot. Import matplotlib.pyplot as PLT. PLT.scatter. Scatter method is used for drawing scatter plot. You know, here we have seen box plot method for drawing box plot, plt.box plot. In the same way, plt.scatter. Scatter is used for drawing scatter plot. Plt.scatter of sales, comma discount. For sales values and discounts values, we have seen scatter plot. Then plt.x label. X label is sales and then y label is discounts. And we have given the title for the scatter plot, sales versus discounts. So this is scatter plot. Then this is how we have used Scipy, Numpy, and then Matplotlib. Now I'll show you. No, this is the Numpy. This is an example for drawing, for representing the sigmoid function by using a scatter plot. So for this, we have imported Numpy first. Import Numpy as NP. Then linspace. This is the most important method that we have seen in Numpy. Linspace. Linspace minus 10 to 10. Minus 10 to 10. It considers, it divides, linspace divides minus 10 to 10 numbers into 100 parts. This is x value. Then y value is sigmoid of x. For this sigmoid of x, we are calling sigmoid method. This is the user defined method. Definition, sigmoid of x, return, will be returning 1 by, its sigmoid, the formula for sigmoid value is 1 by 1 plus e power minus x. Return 1 by 1 plus np dot exponential method is available in Numpy, where we have already imported Numpy and used linspace method. So return 1 by 1 plus np dot exponentiation of minus x. So this is going to be y value. So for this x and y values, we are drawing sigmoid function. For plotting, we have to import matplotlib. Import matplotlib.pyplot as plt. plt.scatter of x comma y. It plots the scatter plot for x and y values, and x label is going to be x values and y label is going to be y values, and the title of this graph is sigmoid function. This is how we have drawn this plot, sigmoid function, by considering x values and calculating y values. And then by using matplotlib, we've drawn this scatter plot. This is a scatter plot by giving x labels, y labels, and then title for this graph. So this is how, this is the scatter plot for sigmoid function. You know, these are the 3 important library functions. First one is Numpy, second one is Scipy, and third one is Matplotlib. This Matplotlib, it's for visualization purpose. Matplotlib has powerful and beautiful visualizations. There are many plots available in Matplotlib, where we have seen box plot as well as scatter plot. We can plot a data frame using plot method. The only thing is that we need to import matplotlib.pyplot as PLT. For Numpy, you have to import Numpy as NP. For Scipy, you have to import Scipy as SP, or from Scipy import star. And in the same way, matplotlib, you need to import it. Then the most important machine learning library is Pandas. Pandas is the most important one. This is very important one. So Pandas refers to panel data or Python data analysis. So for drawing, for considering any data, either from Excel or from CSV, from any stored values or from online site, this Pandas is used. Pandas is used for considering the data and doing pre-processing, for performing any pre-processing operations. There are various methods that are available in Pandas. So this is very important in data science. Relevant data is very important. No, we cannot consider the data that has been there. We need to pre-process it. We have to pre-process the data. Relevant data is very important in data science. Pandas can do cleaning, data pre-processing. All these things can be performed in Pandas. So in Pandas, actually, there are two methods. One is series and second one is data frame. Series is it stores only one column. Data frame stores rows and columns. So Pandas reads the data and then do data pre-processing task, and then we can apply any machine learning or data science algorithms on this pre-processed data. So for that, it drops any null values, fill the null values either by using mean value, median value with any required values. There are various methods like look and unlock are there. It considers only the relevant columns and rows. So the unique values can be considered. So if a value has been repeated many times, it finds value counts. All these are the duplicate methods can be dropped. Null values can be dropped. So all these methods, all pre-processing methods are available in Pandas. Pandas is the most important package. This is used for reshaping and pivoting of data sets, group by data for aggregation and transformations, even for time series, handling multiple operations and data sets like slicing, filtering, grouping, reordering, everything, reshaping. All these methods are available in Pandas. It integrates with other libraries, even like Scipy or Scikit-learn. So it integrates with all these things. So let me open Anaconda Jupyter Notebook and show a few simple example programs on Pandas. Now I'll be opening Python notebook. First thing is we need to import Pandas as PD. Actually, if we see this is the database that has been considered from online store. So this is the order ID, quantity, item name, choice description, item price. So this is this .tsv file. So this file we have considered from GitHub. In GitHub, this data is there. So this path I've considered chip orders. So PD dot in Pandas, there is a method called as read_table is there. By using that, you can use this URL which is there in GitHub and then read the table. We have read the table. This is the table with order ID, quantity, the same. Item name, no, choice description, item price. So we can do any pre-processing which contains 6,000, some 622 rows and five columns. So this is the size of this table. If you would like to see only data frame, this is the pd.read_table that has been stored into a data frame, which contains rows and columns. So we need to store it in a data frame. I've stored in a data frame df. Data frame.head stores. Data frame.head shows only top 5 rows. This is what we have imported. When it is running, it's going to be star. After completion, it's turned into 2. So table, I've read this table, then stored it into a data frame, then data frame dot head. It displays, top 5, 0 to 5. Actually, this is markdown cell For making it as code cell, you have to convert it into code cell. Here you can see code markdown. So headings, all these are available. For running it, you have to convert it to code cell. If it is in the form of markdown, it's used for commenting. If I like to write any comments for our readability, I have to make that cell as markdown. So data frame dot head, it shows 5 rows, top 5. If it is style, bottom 5. No, this is data frame dot pd dot read underscore table. Then if we see this, if I see this one, chip orders, this is my table with these values. But when you move to this movie users, this is my another database. So all are in GitHub only. This is another repository, movie users. So which does not contain any header. 1 separated by pipe, 24 separated by pipe. Then male, M separated by pipe, technician. So this is how it is there. So when you read this pd.read underscore table, so all these separators are there. So when you would like to separate it and store it in the form of table, there is, in read underscore table, you can write separator with pipe, and header is going to be none. Then you check this one. It is stored in a data frame called as mu.head. It shows these values. There is no header. Header is none. So by default, if I have not mentioned header as none, first row is going to be considered as header. So that I've made header as none. You see this one. See, even first row will be considered as header. Here, this header is none. So it has considered header as 0, 1, 2, 3, 4, and the remaining values, and is separated by pipe symbols, and then store it. It is stored as a single column. These are divided and segregated into different columns. Then pd.read underscore table. No, previous data was UFO reports. This is my another database. This also considered from GitHub only. So these values are not separated by pipes, whereas these values are separated by commas. In that case, you have to give separator as commas. Separator as commas. But whereas it has a header, if it has a header, city, colors reported, shape, no, you can use the same header. Separator as comma. Now, if the separator is comma, rather than using pd.read underscore table, there is one more method called as pd.read underscore CSV. pd.read underscore CSV. Directly, you can use pd.read underscore CSV and then give this path. Then there are, now for accessing particular column, there are 2 ways of accessing. One is dotted notation and second one is bracketed notation. If it's dotted notation, dff.shape. Now dff.shape, you can access only dff.city. You can access only city. No, that is dotted notation. So if this attribute has, if the attribute is single entity, then there is no issue. But if it is like shape reported, if there is a space in between, in that case, you have to use only bracketed notation only. Otherwise, it generates error. So you have to use DFF and within square brackets, use the attribute name. If you use dot shape reported, it generates error because there is a space. It's 2 words. So this is how we need to import pandas. No, that shape, head, all this also used. So you need to import pandas and then read table, apply all pre-processing methods and then proceed it. So you can handle missing data. All pre-processing can be done by importing pandas. So if you see this one, no, this missing data contains NaN values. This is a CSV file which I've stored in my D colon itself. I've not considered either from GitHub. I just created a simple file with the name of missing data.csv, and read underscore CSV is used for reading CSV file. Otherwise, you can use read underscore table. Then the shape and columns. So if it is null dot sum, it displays all these things. If it is, if it is null values, you can fill null values by using its mean. You can fill null values. Fill and name method is used for filling null value with median. Now, if it is null, it will be displaying. It's true if there is no data. Not null. It's going to be true if there is data. Even you can fill this null value with mean. You can fill null value with for particular attributes also you can fill it. So this is all these are the pre-processing methods that are available. Actually, in Pandas, there is a series and data frame. Till now, we have seen data frame. Series is a very simple one. It's used only for a single column. Even if you don't want it, you can drop NA method is used for dropping. So all these are the pre-processing methods. And the most important methods are look and iLook. There is a simple difference between look and iLook. This is also for indexing and slicing. For we can access, this is colon for all rows and survived because sex embarked. Only for these columns we are accessing. If I want to use index location, like for numbering, data frame dot look of all rows and numbering, we can use numbering and then display only those particular columns. This is how we can use look and iLook method. Data frame dot look and data frame dot iLook method. So this is the next important Python library that's called as Pandas. So we have seen Numpy, Scipy, Matplotlib, and then Pandas. This is Pandas data. It's used for panel data or Python data analysis. So we can do pre-processing. This Pandas is actually the most important among all these things. You can do filtering, grouping, reordering, even for time series also. So the next important one is Sklearn. It contains various machine learning algorithms. Sklearn has various algorithms for regression, classification, clustering, for all these things. I'd like to show a linear regression if time permits. Now let me open my Anaconda Jupyter notebook. As there is lack of time, let me brief this one. And this is Sklearn or Scikit-learn. This contains many machine learning algorithms, all classification algorithms like tree-based algorithms, all algorithms are in Sklearn, Scikit-learn. No, even classification, clustering algorithms, all algorithms exist here. So for this is a simple linear regression. You know what's meant by Pandas. Pandas is for reading data and for pre-processing. Numpy is for multidimensional arrays. Matplotlib is for plotting purpose. Then we have imported sklearn dot model selection, import train underscore test underscore split. Then from sklearn dot linear model, have imported linear regression. Imported train underscore test underscore split, and then also have included imported linear regression. From sklearn, import matrices. For measuring purpose, I've imported all these things, matrices. So this is all these things. First I've done importing, then run, it's being run, and then finish running. D colon students course dot CSV. This is students course. It's a simple CSV files which I have stored in D colon. Read CSV. Then its shape is only 12 rows and 2 columns. This is describe and histogram. Then dataset.plot of, it contains only hours and scores. This is our studied a student database. If these many hours studied by a student, then how much percentage that he scored? This is the title is hours versus a percentage. X label is hours studied. Y label is percentage score. PLT dot show. This is the data that we have considered. Then dataset dot ilook all rows, and for X we've considered the last column. iLook of last column, then dot values, and Y is this first values. Then we have divided train underscore test underscore split. For test data, 20% of the data is being used for test and 80% of the data is being used for training. You can change it. You can use, if I've given 0.3, testing 30% and training 70% of the data is being used. Then I've used linear regression method. This linear regression, as I've already imported linear regression from Sklearn dot linear model, import linear regression, use this linear regression method, and then regression dot fit of X train, comma Y train. Calculated, printed regression intercept, and then coefficient. So this, this we can calculate. I can show all the calculations and show how this values also, but time is running out, so it's not possible for me to all such things. Regression dot predict of X test pi predict. Now will be, these are the actual values and these are the predicted values. These are the actual values and these are the predicted values. So this is the linear regression that we have done, and calculate the error with actual values and predicted values. Actual is 88, predicted is 86.28 in the same way. So for measuring this error, there are various measures for calculating the errors. These are the three measures that have been considered: mean absolute error, mean squared error, and then root mean squared error. Root mean squared error. SQRT method have been used here. So one is absolute error, mean squared error, and root mean squared error. These are the errors that have been generated by applying linear regression. This is the Pandas library. Pandas. So in this example, we have used Sklearn, linear regression, and then Pandas. By using Pandas, we have imported a data set, and then we have, for scattering purpose, we've used Matplotlib, and then for creating arrays, we've used Numpy. So till now, we have seen the most important machine learning packages or data science, data science packages like Numpy, Scipy. Then we have used Pandas, then Sklearn, Matplotlib. Numpy, Scipy, Matplotlib, Pandas, and Sklearn. These are the very important ones. Numpy is for numerical computations and multidimensional arrays. Scipy is for calculating mean, median, mode, standard deviation, all such functions. Then Matplotlib is for plotting purposes. Then we have seen Pandas. It's used for reading a data frame and then doing pre-processing. Sklearn, it's the many important machine learning algorithms exist in Sklearn, like regression, classification, clustering, all time series, and all machine learning algorithms exist in Sklearn, where we have seen linear regression. So these are the most important libraries in data science. Then we'll see some of the deep learning libraries in Python: TensorFlow, Keras, and PyTorch. This TensorFlow is developed by Google actually. PyTorch, it's a torch framework and is a strong competitor to TensorFlow, which is developed by Facebook. No, Keras it runs on TensorFlow, supported by Google. Actually, if you see this TensorFlow and Numpy, it's an extension to Numpy actually. By using tensors, we can create n-dimensional tensors, and it's supported by Google. Actually, Keras also is supported by Google. PyTorch, it's a competitor for TensorFlow. It's developed by Facebook. So you can do all deep learning algorithms. You can create various neural network models and different layers can be created. Now for inputs, how you're training the data, how weights are being changed and checking the outputs. So all these things you can import PyTorch and you can check it. You can check how these are being generated. So these are some of the important libraries in Python, that were machine learning, deep learning, all data science libraries, packages in Python. So this is how data is being handled. Data is being pre-processed, applying all these algorithms and generating in a relevant format, training our model, testing the model by using train underscore test underscore splitting, training, then being testing, and then checking its accuracies by using various accuracy measures. Regression in one way I'll be checking, and in classification another way we are going to check. We use different measures. There are different algorithms that can be tried in Python. Actually, Python has a rich set of libraries. So because of that, Python is much popular, and industry also Python is being used because of all these machine learning and deep learning libraries. Like all these important libraries that I've discussed in machine learning, Numpy, Scipy, Matplotlib, then Pandas, and then Sklearn. And in the same way, in deep learning, TensorFlow, PyTorch, and Keras. So all these are the very important libraries in Python. Thank you so much. Thanks for all organizers, participants, and especially I'd like to thank Anusha for coordinating the entire session and for making me to come online and finish the session properly. Thank you so much, Anusha. Thank you all.
Thank you very much, ma'am, for delivering such an insightful and inspiring session. We sincerely appreciate your time, expertise, and the way you engage the participants with such clarity and enthusiasm. I also extend my heartfelt thanks to all the participants for their active involvement and keen attention throughout the session. With this, we conclude day 4 of our faculty development program. We look forward to meeting you all again tomorrow for another exciting and knowledge-filled session. Thank you, one and all. Especially thanks to Jahnavi ma'am.
Thank you.
Thank you, ma'am.
Thank you so much.